In the world of global logistics, a single tiny glitch can spark an absolute catastrophe. But what if? What if you could predict that glitch before it ever even happens? Today, we're going to dive into how AI is making a massive shift in logistics, moving from just reacting to problems to actually predicting them. We're talking about making sure the global supply chain, well, never breaks.
So let's paint a picture. A huge shipment is making its way across the ocean. Everything looks fine. But then the tracking dashboard just freezes. The digital thread that connects everything has just snapped. All because one single API call, basically a little request for data between two computers, failed. And now, warehouse updates grind to a halt. Customer portals are totally useless. It might sound like a small tech issue, but trust me, the reality is way, way more serious.
And just like that one little failure spirals into a total business catastrophe. We're talking about missed deadlines, which means broken promises. We're talking about clients who are getting more and more frustrated, losing trust. And of course, costs are just skyrocketing as teams scramble to put out the fire. So it begs the question, why are these supercritical systems so fragile in the first place?
Well, it all comes down to the unbelievable complexity of a modern supply chain. You can almost think of it like a giant digital Jenga tower made of all these interconnected parts. And if just one of those little bricks is loose, the whole thing can get pretty unstable pretty fast. This fragility, it really comes from just how complex everything is. See, modern logistics isn't just one piece of software. It's this incredibly delicate web of systems for transportation, for warehousing, for management, all woven together. Then you throw in constant software updates, this massive dependency on live data from all your partners, and this intense pressure to scale up. And what you get is a perfect recipe for disaster, where one tiny error can set off a huge cascading chain reaction. And here is the real kicker. The tools we've been using for years to check for these kinds of errors, our traditional automation, they just can't keep up anymore. They've actually become the bottleneck, slowing down innovation right at the moment we need to be moving faster than ever. Let's look at the difference here, because it's huge. On one hand, you've got traditional automation. It's reactive, it only finds bugs that we already know to look for, its scripts are super brittle, they break with every little system change, which means teams spend more time fixing the tests than actually finding problems. But then, on the other hand, you have AI-driven testing. It's predictive. It learns and adapts to changes instead of breaking. It becomes an accelerator for new ideas, not a roadblock. And this is exactly where AI and its predictive power come into the story. This isn't just a small improvement, it fundamentally changes the entire approach from constantly playing catch-up to actually getting ahead of the problem. So what is AI-driven test automation, really? Well, at its core, it's a system that actually thinks. Instead of just mindlessly following a script or a checklist, it learns. It learns from past results, from system logs, from live data. The best way to think about it is like a really smart assistant that just gets better and more insightful with every single task it performs. We can really boil this whole thing down to three core ideas, three pillars. First, there's prediction, the ability to find those potential weak spots before they ever have a chance to break. Second, autonomy. It can run and even fix tests all by itself without a human needing to step in. And third, continuity. With this, testing isn't just a one-time thing. It becomes this constant, ongoing process that keeps the system safe 24/7. Okay, but how can a system actually predict the future? It's not magic, right? No, it's a really powerful data-driven process that works in 4 key steps. Okay, so first, the AI learns patterns. It crunches all this historical data to spot the little early warning signs of trouble. Then it actively detects anomalies in live operations, things like a sudden spike in data or an API that's running a little too slow. Next, it simulates the impact. It predicts how that one small issue could cascade into something much bigger. Remember that shipment from Shanghai? This is the exact moment the AI would have predicted that a slow API would eventually freeze that whole dashboard. And finally, it can trigger self-healing actions, automatically launching a fix before any human even knows there's a problem brewing. Now, this predictive power, it isn't just about better testing. It's about enabling a completely new vision for how logistics works. The ultimate goal here is something we call zero-touch logistics. Zero-touch is exactly what it sounds like. It's a future where these massive systems largely manage themselves. We're talking way fewer manual tasks for your teams and much faster, smarter responses when disruptions happen. It's a world where the platforms themselves can test, detect, and heal, which frees up the humans to focus on the big strategic decisions. And hey, this isn't some far-off theory. This is delivering real-world value right now. Companies using this are seeing incredible, tangible results, like a 50% increase in the speed of their release cycles. That's huge. And that 50% speed boost, that's just one piece of the puzzle. This same tech also leads to a 50% reduction in all the time and effort needed just to maintain tests. And, maybe most importantly, a really significant drop in costly system downtime. These are the kinds of numbers that directly impact the bottom line. All of this is building towards the ultimate evolution in logistics tech, the creation of a truly self-healing system. A self-healing supply chain is, well, it's pretty much what it sounds like. It's a system that's smart enough to automatically find a problem, run its own tests to figure out the root cause, and then apply a solution, all before it ever impacts a single customer, and without an engineer getting paid in the middle of the night. This whole thing works as a continuous loop. It's really elegant. First, you have observability. The system is always watching key data flows and APIs. The second it spots an issue, it triggers AI-driven testing to diagnose the cause. And finally, it applies automated fixes to correct the problem on the spot, keeping the supply chain running smoothly and making it incredibly resilient. So if you take away just one thing from all of this, let it be this fundamental shift in mindset. We're moving away from a world where we're constantly reacting to fires and into a world where we can actually predict where the sparks might fly and stop them from ever igniting in the first place. This big shift leaves us with one last really crucial question to think about. In today's super competitive and fragile logistics world, it's just not enough for your systems to be working. The real question we have to ask is this: are they learning, predicting, and evolving to meet the challenges of tomorrow? Thanks for joining me for this explainer.